Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. Expand the expression. So, if I were to expand this, we're just going to go through some of these rules, kind of quick. So, if I were to expand this, w to the third to the fourth, that means w to the third how many times? 4 times. So this means w to the third times w to the third times w to the third times w to the third. Rewrite the expression. So how would I multiply all the, what would my answer be if I multiply w to the third, w to the third, w to the third, w to the third? W to the what? What do I do with these exponents? Not multiply them. Add them, right? Because this means I have 3 w's, right? And then I have 3 more w's. W times 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 w. Okay? So altogether, how many w's would I have? 12. Okay? W to the 12. Anyone think they might recognize a rule with, what about the, how does this 3 and 4 compare to this number right there? Multiply. Okay? So this, that's called the power rule. We're going to do another one, I think. Okay? Oh no, the power rule. Okay? Says, if you have a power raised to a power, I have to look in my notes. Power rule says, if you, oops, not yet, going back, go back. Power rule says, if you have a to the m raised to the n power, that's equal to a to the m times n, like that. That's the power rule. We're going to do some examples in a second. Okay? So if you have a, that's a power to the power. That's not the same as this, right? A to the m times a to the n is equal to a to the m plus n, right? So this is different than this, right? This says whatever I have here, I raise it to a power. This says it's this to the this times this to this. So this is not the power rule. That's called the product rule. So moving on, let's do a couple examples. 6 to the 4 times 6 to the 2 is equal to 6 to the what? 6 to the what? 8. Okay? 6 to the 8. X to the negative, x to the 3 times x to the negative 9 is equal to what? X to the negative, x to the 3 times x to the negative 9 is equal to x to the
Negative 27.
negative 27. That's correct. Okay. You guys, you just multiply the exponents. X to the negative 27, which can be written as, if I just wanted positive exponents, that's the same as 1 over x to the 27. Okay? So that's the power rule. More. Find the expression using the definition, rewrite the expression, compare it with it. So in this case, this means, okay, this means h squared t, 5 times, right? Times h squared t, times h squared t, times h squared t, times h squared t, right? H squared t. How many h's do I have altogether? 10, right? So that's equal to h to the 10, t to the, how many t's do I have altogether? 5, okay? So that's kind of the second version of the power rule. Is that raising a power to a power, okay? So if you have, so let's see if that's the next. Raising a power to power. So if you have something like a to the m, b to the n raised to the I don't know, let's put another letter. Let's put a P here, okay? That's equal to A to the MP times B to the NP. Do you guys understand what all those letters mean? So if this is raised to a power, then you just multiply these two exponents. And if this is raised to a power, you just multiply those two exponents. Yes? No? Going too fast? Too slow? Okay, moving on then. Okay, so who can give me the answer to this one? I'll give you $1. No, a valuable bonus point. Who's going to give me this one? Come on, you can do it. J to the 2. Go ahead, Ben.
J to the 22.
Yes.
P to the 55.
Yep.
G to the 11.
G to the 11. Right? Because even though there's nothing here, it's understood that if there's nothing, no exponent, it's understood that the exponent is 1. Okay? Questions on that? Who wants to give me the next one? Who wants to give me the next one? You could leave exponents negative. Go ahead, Trey.
3u to the negative 4.
No, 3u is, the 3 is by itself, right?
U to the...
Yeah, but 3 is raised to what power? This is...
negative 6.
No, just 1 times negative 2. What's that?
Negative 2.
Negative 2. So it's 3 to the negative 2, u to the
Negative 4.
negative 4, w to the...
Negative 4.
There you go. Okay? And then if you did want to write that with only positive exponents, it'd be 1 over 3 to the 2, u to the 4, w to the 12. Yes? And if you want to be better, you could even make this into a what? What's 3 to the 2? What's 3 to the 2, India? What's 3 times 3? 9! You were somewhere else, weren't you? 1 over 9, u to the 4, w to the 12. There you go. Okay? Okay, more rules, more rules. I know you like rules. So, oh, I have to give Trey his point. Who else gets a point? Did you get a point? I got you a point. Trey S. There you go. All right. Moving on to the next rule. Hi, May. Who wants to guess what this is? Anyone want to guess what the answer to this one is without expanding it? Well, this means, right, h squared over w to the 4th times h squared over w to the 4th times h squared over w to the 4th. How many h's do I have altogether? 6, right? How many w's do I have altogether? 12, right? How could I have got that without having to write that all out? Just multiply the exponents, right? Multiply the exponents. So the next rule says, lots of rules here, but they're all kind of related, right? That if you have something like, okay, raising a quotient to a power. Where's that one? A to the m over b to the n raised to the, let's call it t this time, is equal to a to the mt over b to the nt. All right, so basically you just multiply the exponents. If there's no exponent here, you just multiply it times 1, right? So you ready to do some examples? I should give you whiteboards to do this. I don't want to deal with it right now. Short day. All right. Here we go. Who can give me the answer to this one? Valuable bonus point. Go ahead, Blake.
X to the 15.
Yes? It's not 4 times 5, it's 4 to the 5, right? It's not 20, so it's not 4 to the 5, right? Which is a big number. So it's not 4 times 5, right? People make that mistake all the time. Okay. Who wants to give me this one? Go ahead. I'm going to give it to Daniela.
8 to the 8th.
8 to the 8th.
And
B to the 12th. What's is on the bottom?
Over 7 to the 4th.
7 to the 4th. Very good. Okay, I'll give you those 2 people points. Play king. Play king and Daniela, you. Yay. Daniela, you. The girl. You the girl. Okay. Okay. Here we go. I know I'm going. Uh-oh. 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 I don't even have any examples for this, do I? Okay. So maybe I should make up my own example. Say I have something like 8 to the negative n. I don't like that one. Quotient to a negative power is, so say, for example, okay, I have 2 raised to the 3 over x raised to the 4 raised to the negative 2 power. Using the last rule that I just learned, okay, this would be 2 to the negative 6 over x to the negative 8. Yes? But 2 to the negative 6 is the same as 1, let me rewrite this, is 1 over 2 to the positive 6. And x to the negative 8 is the same as 1 over x to the positive 8. This is a fraction divided by a fraction. So this is the same as 1 over 2 to the 6, copy, dot, flip, equals x to the 8 over 2 to the 6. Okay? That didn't. So in other words, if I raise something to a negative exponent, all I have to do is flip this upside down and raise it to the positive exponent, like that. Okay? So if you have a fraction raised to a negative exponent, you can just flip it and rewrite it as a positive exponent. Another way I can think about it, I got a better way to think about it. 1 over a over b to the negative n is the same as a, don't do that, is the same as a over, sorry, you know what, 1 over a over b raised to the positive n, which is the same as copy dot flip b over a excuse me, to the positive n. Okay? Just remember this rule. If you're raising a fraction to a negative exponent, just flip it upside down and make it positive. Okay. We're going to do a couple examples and then I think we'll be done. Okay? So let's look at this one. That was negative exponents 3. Who can tell me how I could rewrite this one? Give me $1. Valuable bonus point, I mean. Go ahead. Who's got this one? Quotient to a negative power. First, go ahead, Anna.
3y over
Yep.
2x.
Yep.
Third.
To the 3rd power. Very good. Sorry, that got messed up. Very nice. 2x raised to the 3rd power. Which I could expand that, right, as 3 to the 3rd, y to the 3rd, 2 to the 3rd, x to the 3rd, which would be 27y cubed over 8x cubed. Do you guys understand that part? But if you did this, that's using that last rule, right? And then I used another rule. I said I have to raise this to the 3rd power, this to the 3rd power, that to the 3rd power, and that to the 3rd. Right? And then I expanded 3 to the 3rd into. Okay, who wants to give this one a shot? Go ahead, Will.
3 with the power of 2. 3.
Just do the first step. Do it one step at a time.
Yeah, 3c negative 4.
Yep, that goes up top.
Over 2a power of 2x.
Yep. Raised to the
2.
2. Then I can use the next rule. So what would the next rule say?
3 with the power of 2.
Uh-huh.
C negative 8
Yep.
over 2 power of 2
Yeah.
with a power of 4
Yeah.
x power of 2.
Yes. And then one more step. Make this positive.
So it's c over
What's on top? What's 3? If I did it, what's 3 squared?
3 squared.
3 times 3.
9.
9. What's 2 squared?
4.
Okay. The c comes downstairs and becomes what?
Positive.
Positive. A to the 4th, x to the 2.
Okay.
Lots of steps, right? So if you left this as 3 to the 2 and 2 to the 2, that's okay. But when there's small numbers like that, it's okay to go ahead and expand them out, right? Okay, very nice. And I get the point. And you got too many bonus points already, Will. It's okay. All right, is that the end? Is that the end? Math Excel, 8 questions. That's it. 8 questions in Math Excel. So you can get started. Yeah, 15 minutes, right? Yes. Chase, I'll try to get you. I'll try to get you working. Okay. So hold on. Let me find my recorders.